Dear student, today my lecture is about role of friction in engineering application. We are going to see the importance of friction force in a various engineering application. The objective and outcome of my lecture is given in the list. The learning objectives are we need to understand the importance of the friction force in engineering application, the role of friction coefficient of materials, and importance of the static and dynamic friction forces. The learning outcome after this lecture, you can solve the frictional force associated with engineering problems. You can design a high and low friction device using various engineering application. For example, in a real life issues, skidding of a moving car, automobile vehicle on icy road. This happened in the winter season and Western Malaysia. In fact, you look at this video, you see that the car which is spinning and skidding because of the icy road. The very reason behind this happening is because the low friction between the tire on the road. The lubricated surface gives a low friction, so therefore the vehicle skid and create a lot of accident. So it is very important that we should have a very high friction force between the rubber tire and the road. In case on ice, there is a very less friction force. In case of rubber and road, rough road, there is a high friction force. So the high friction force gives a more control for a vehicle. The role of friction force basically play an important role. In fact, for example, it is responsible for keeping the object on a surface without slip. Man walking on the floor without falling and slipping, and moving a car, automobile vehicle on the road without skidding. As spike under the athlete, sportsmen should give more control. Ice skating, control motion of the scatter. So it is a very important that these forces, the friction force is important if you want to have a more control on these real life situations. So whether these forces are static or dynamic, let us look into that. The load due to its mass of this object or the mass of the car is W, and the applied load is P. Always the friction force act against the applied load, and the normal reaction force which is coming from the counter surface. You see that the force when you stand, it reaches a range. For example, if the friction force is more, it is still in equilibrium. When you reach Fm, that is kind where the impending motion will happen. After the friction force reaches Fm, then it started to move. That is the kinetic friction force. You can see the time relevant diagram on this graph and this. So when the friction force is less than the applied force, the effective applied force and resolved forces, then the vehicle moves or the block moves. If it is less than that, then it is the static equilibrium condition, doesn't move. So in both cases, the friction coefficient in a static equilibrium condition is called mu s, that is the static coefficient of friction. In kinetic condition, kinetic motion, the friction coefficient is called the kinetic coefficient of friction. So we look into that various materials: steel on steel, aluminum, copper on steel, rubber on concrete, wood on wood, glass on glass. There is very material listed here, friction coefficients. If you look into that, the synovial joints, the human joints basically have a very less coefficient of friction. And the Teflon on Teflon, you see the rubber on concrete, which is having about a wet condition, it is a 0.3, and dry condition is 1.01. So that's the reason why this skidding happened because of low friction. Teflon is the lowest in the material, it's about 0.04. But overall, if you look at the static and the kinetic friction, and the static friction is always higher than the kinetic friction. So it is very important that when you make a design, we should take consideration of this friction coefficient of the interface material. So let us look into the two cases. One is the block on the plane. So applied force is a P, and the load due to its own mass W, and the friction force is acting against the applied force, and the counter force from the surface, counter surface is reaction force, basically you can say. And then in the case 1, the friction force is greater than the applied force, then no motion. Again, in the case 2, if the friction force is equal to the applied force, the impending motion. Case 3, the kinetic force is less than the applied force in the kinetic regime, and then it happened, the motion happened. So that's a very important aspect. When you incline, then you have to resolve the force. In this case, again, if you look into that, when we incline the plane theta, if the angle of the incline is a theta, then you have to resolve the forces. That is W resolved in horizontal component is a W sine theta, vertical component W cos theta. That the reaction force, similarly you have to resolve it. Then you have to make the equilibrium balance, equilibrium condition, and then you have to find out the various aspects of this force involved in the cases. So we learned various kinetic and static friction conditions. This is a problem which I like to give as an assignment. Just go and look into that. So if you have any query, now itself you can ask the clarification. The problem A, which I am going to give as an assignment, is driving a car or dragging a stone on a slope. Use a realistic value of mass for a car and apply load. Assume that kinetic friction and static friction is 0.25 and 0.15 is the kinetic friction, and the inclined angle is 20 degree. So find out the force required to maintain the static equilibrium. If it is a car, how much brake force or how much friction force needed to maintain the car in a static equilibrium on a slope. So if it is balanced, then friction force, applied force are equal, and no motion happen. So in the case, if there is a net force greater than the static equilibrium force, then what happened? Net force is across the upward motion, and net force is negative, then downward motion. That is from the basic of Newton's second mass and acceleration is called net force. So whether it is upward motion or downward motion, you can understand that. Depends on the realistic value you give it. Whether you drive upon the slope or you slip downwards. So it is all about if the brake fail, then it is the case that you are the downward motion uncontrolled accident could happen. So the problems B, the second part of this assignment, which I wanted to solve the problem A in an IC condition. Basically, it's a low friction force. Assume that the static friction is 0.1 and kinetic friction coefficient is 0.05, and the same inclined angle. This you need to think a little bit more. This will give you, in fact, your new idea. How can you design your low friction, your interface for a low friction condition or high friction condition. So, dear student, I hope if you have any clarification, I can explain to you. So, thank you for listening to my lecture. Submit your assignment through Moodle before lecture and to next lecture. So, I hope that this would, in fact, my lecture, you got your insight about the friction and the role of friction and the necessity for having a friction and interface. Thank you, dear student. We hope to see you in the next